135 million people currently occupy the Sahel Belt, a narrow strip of land where the battle against the encroaching desert is lost at a rate of tens of thousands of hectares of fertile soil every single year. Life here is quietly retreating as the environment transforms into a landscape of dust and rock. Why would anyone consider releasing tortoises into such a desolate wasteland to combat this destruction? It only looks obvious that a larger, faster intervention is required to save the soil. But in reality, these slow-moving creatures possess a unique biological function that might stabilize the entire ecosystem from the ground up. The Sahara operates like a vast machine of aridity, stretching across a territory larger than the entire United States of America. It is visible how the northern winds relentlessly drain the remaining moisture from the ground, causing the majority of young plants to wither and die before their roots can penetrate the hardening surface. This leaves every human effort to restore the greenery hanging by a fragile thread. Over 360 million hectares comprise this extreme climatic system, which is not merely a desert, but an expansive, self-sustaining engine of heat. One can notice how the equipment used for traditional irrigation often fails in these temperatures, which reach 50 degrees Celsius. The process is only gaining momentum. Because the Sahara acts as an environmental barrier, the Sahel serves as the final line of defense for millions of inhabitants. It seems simple to plant trees to stop the sand, but the soil lacks the natural fertilization and seed dispersal mechanisms usually provided by local fauna. This is where the introduction of the tortoise becomes a calculated technical strategy rather than a random ecological experiment. Everything only gets more complicated as the desertification line moves further south into the inhabited zones. Tens of thousands of square kilometers of once productive farmland are rendered useless, forcing a total rethink of humanity's strategy against the advancing sand. The camera glides along the cracked earth where not a single blade of grass remains. At first glance, the tortoise appears fragile and ill-equipped for such a monumental task. Yet these animals act as mobile irrigation and fertilization units, processing dry vegetation and depositing seeds deep within a protective layer of organic matter. It gets more complex further on. Scientists are now observing how these biological agents interact with the sun-scorched earth to create microhabitats for new growth. One can notice the slow movement of the tortoises as they navigate the dunes, their shells reflecting the intense ultraviolet radiation. They represent a slow but persistent force against a climatic system that has dominated the continent for millennia. Thus, the project begins its initial phase of ecological reconstruction. The integration of biological life into the arid mechanical system of the desert continues without haste. 40 degrees Celsius. This is the standard temperature the ground reaches during the peak of daylight hours in the Sahara, baking every exposed surface into a hardened crust. Why does such intense heat present a more significant threat than simple lack of water? The high temperature alone is destructive, but it is the rapid cooling at night that creates a violent thermal cycle capable of fracturing the physical structure of the soil. But this is just the beginning. In many regions of this desert, rain is a phenomenon that may not occur for several decades at a time. It seems simple to blame the lack of precipitation for the state of the land, but in reality, the Sahara's ability to drain moisture is its most terrifying characteristic. Evaporating at a rate of 236 inches per year, any moisture from rare rains vanishes almost instantly. One can notice how the water evaporates from the surface before it has a chance to penetrate the deep layers of the earth. The process is only gaining momentum. Hot winds and sandstorms sweep across the exhausted landscape with relentless frequency. These winds carry fine dust to the edges of the desert, where it covers and suffocates young seedlings the moment they attempt to emerge from the ground. Transition to the next level. Between the arid Sahara and the southern tropics lies the Sahel, a fragile frontier of life that spans a semi-arid belt of land. 135 million people reside in this zone, relying almost exclusively on small-scale farming and livestock herding for their survival. Because the balance is so delicate, even a minor shift in water availability can escalate into a crisis. The Sahel receives a limited amount of rainfall, but it is never sufficient to offset what the prolonged dry seasons take away through natural processes. Everything only gets more complicated. At first glance, The erosion of the soil looks like a gradual thinning of the surface, but in reality, it transforms the earth into something as solid as stone. Once the topsoil is stripped away by wind, the exposed ground hardens and loses its ability to absorb any water. Rainwater can no longer infiltrate the deep layers, and plant roots find no anchor in the compacted medium. The ecosystem's capacity to recover begins to disappear completely. It gets more complex further on. This environmental degradation does not reveal itself through a single dramatic event. Instead, it manifests in the smallest technical details. Shrubs growing sparser, grasslands shrinking, and herds traveling greater distances for forage. One can notice how cultivated fields are slowly abandoned to dust and silence as the land loses its regenerative power. Why have scientists recently turned their attention to the African Spurred Tortoise, also known as the sulcata? The species was once widespread across the entire Sahel. As livestock grazing and habitat loss accelerated, the tortoise population declined sharply until they occupied only 16% of their original range. When the tortoises vanished, the specific ecological roles they fulfilled disappeared as well, causing land degradation to move even faster. At first glance, reintroducing a slow-moving reptile to a desert seems like an implausible solution for a massive environmental problem. But in reality, their biological adaptation over millions of years to arid conditions makes them ideal candidates for local conservation. Since the mid-2000s, organizations in the Furlough region of Senegal have recorded high survival rates during reintroduction efforts. These tortoises are now showing clear signs of natural reintegration into the wild. The equipment of modern conservation is now being used to track these animals as they move through the landscape. Although these initiatives are not yet a large-scale solution to the spread of the desert, they provide a new technical perspective on ecosystem restoration. The material for a new environmental balance is being laid down one step at a time. Thus, the project reaches a stable phase, opening the road to further observation of the species in its natural habitat. 8,000 kilometers. That is the total length of the Great Green Wall, a project spanning the entire width of the Sahel Belt from Senegal toward the eastern coast of the continent. Why would researchers focus on the slow movement of the sulcata tortoise instead of such a massive industrial undertaking? It only looks obvious to prioritize human speed over biological processes, but in reality, the tortoise possesses a behavioral mechanism that has defined its existence for millions of years. Digging is the specific action that captured scientific attention, as it addresses ecological functions that were once broken. This process begins with the physical anatomy of the animal. One can notice how the powerful forelimbs, shaped like natural shovels, drive into the earth to excavate shelter burrows several meters in length. These tunnels often reach depths of 3 to 9 meters, serving as vital infrastructure for survival in arid climates. But this is just the beginning. In the Sahel, the ground is frequently baked into a hard crust that resembles concrete in its density. This impenetrable layer prevents rainwater from entering the subsoil and causes fertile topsoil to be swept away by the wind. However, as the tortoise begins to dig, the rigid structure of the earth is broken apart. The soil is turned over and loosened with a mechanical force that humans could only replicate by utilizing heavy machinery. The equipment of nature operates at a different rhythm. Each individual burrow functions as a breathing chamber for the land, allowing rainwater to infiltrate deeper into the subterranean layers, while simultaneously improving the circulation of air underground. On the surface, the footprints and digging marks of the animals create countless micro-depressions. It is visible how these small indentations trap seeds and retain moisture that would otherwise evaporate. The process is only gaining momentum. Each tortoise acts as a natural plow, and when multiple individuals coexist in a single area, these small physical impacts link together. This phenomenon is described by scientists as redesigning ecosystems from the soil up, gradually improving entire stretches of degraded land. It gets more complex further on. Humanity did not initially choose the path of native ecological solutions. Long before these biological methods were taken seriously, the Sahel had been placed into a much faster and more ambitious gamble. This was the Great Green Wall, launched in 2007 by the African Union to restore land across the entire region. The transition to the next level of restoration had begun, moving from local biological engineers to a continental strategy. The material of the landscape was being reshaped by two very different forces. From here, the transformation moves to the next phase of processing. 8,000 kilometers. This is the immense distance the original vision of the Great Green Wall intended to cover, stretching from Senegal in the west to Djibouti in the east. Why was such a massive biological barrier conceived in the first place? To the architects of the project, a continuous wall of trees seemed the only way to halt the southward expansion of the Sahara Desert. But without understanding the local climate, even the most ambitious blueprints remain vulnerable to the reality of the African Sahel. 100 million hectares of degraded land were targeted for restoration to provide sustainable livelihoods for millions of inhabitants. But in reality, the Sahel operates by its own physical laws, characterized by erratic rainfall and prolonged searing droughts. One can notice how the limits of large-scale planting were quickly exposed as the young trees struggled against the heat. International reports from the end of 2023 confirmed that only 15 to 20% of the overall targets had been achieved. But this is just the beginning. In many sectors, the young saplings perished before their root systems could penetrate the arid soil. They succumbed to intense sandstorms and the physical absence of long-term irrigation. It seems simple to plant a tree, but in reality, survival depends on a constant supply of water that the region lacks. Local communities were sometimes forced to uproot the surviving vegetation for firewood, as it was their only physical means of survival. The project continues to take shape piece by piece, but it has left behind a profound technical lesson. Humans cannot impose their mechanical will upon the shifting sands of the desert. The Sahel does not merely require a static wall to stand against the forces of nature. It requires ecological solutions that listen and adapt to the rhythm of the land. If the Great Green Wall sought to redefine boundaries on a map, the sulcata tortoise reshapes the landscape through a different mechanical process. The process is only gaining momentum. Step by slow step, the heavy reptiles move beneath the surface of the parched land. As their tracks gradually imprint the sands, their physical impact extends far beyond the small areas they inhabit. Over time, the zones frequently visited by the tortoises emerge as ecological anchor points where life returns earlier than in the surrounding terrain. Vegetation begins to regenerate in these spots first, forming sparse but vital patches of green that stabilize the shifting soil. Insects follow the moisture, then small herbivores arrive, and eventually, lower-level predators enter the chain. A clear and orderly progression of biological recovery takes shape without any dramatic sudden shifts. Scientists categorize this phenomenon as clustered restoration rather than a large-scale recovery effort. It gets more complex further on. In an environment as harsh as the Sahel, it is these scattered pockets of life that determine the capacity of the entire ecosystem to endure. The sulcata tortoises do not green the region overnight, nor do they reverse desertification in the short term. Instead, they perform a quieter mechanical task, preventing the ecosystem from reaching a point of total collapse. This allows natural processes to continue moving forward at their own pace. Early results from reintroduction programs in Senegal quickly drew the focus of the international conservation community. At the center of these efforts sits the Ferlo Biosphere Reserve, where the program has operated continuously since 2006. Conservation reports indicate that approximately 80% of the tortoises reintroduced have survived the transition to the wild. One can notice how many individuals have already begun to reproduce, which is a rare outcome under such extreme conditions. These successes provided the technical groundwork for expanding the model into Mali, Niger, and Chad. In these specific countries, the tortoises are bred under strictly controlled conditions and released in small, manageable batches. They are monitored over the long term to minimize any biological risks to existing wild populations. The reintroduction is no longer merely an effort to save a single species from total extinction. Everything only gets more complicated as the project integrates into a broader ecological restoration approach. Restoring even the smallest natural links can generate resilient and lasting impacts across the semi-desert. Yet tortoises were not the only species brought back to the sands of the Sahel. Before their return, the land witnessed the total disappearance of a much larger and faster animal, the Scimitar-horned Oryx. For many centuries, the oryx roamed the grasslands, perfectly adapted to the intense heat and lack of water. But the expansion of livestock grazing and the use of hunting rifles pushed the species to the very brink of survival. By the end of the 20th century, the oryx had officially vanished from its wild habitat. Its name survived only on conservation lists and within distant captive breeding facilities. Transition to the next level. A bold effort began in Chad in 2008 to return the animal to its ancestral territory. After years of preparation, the first 25 individuals were released into the wild in 2016. Then something occurred that few experts dared to expect during the initial phase. Calves were born within the first year, marking the first natural reproduction of the species after decades of absence. From that moment, the oryx population began to grow with steady momentum. By 2023, the total numbers had surpassed 600 individuals. This growth demonstrated that the reintroduction was no longer a mere experiment, but a functional reality. In 2024, the status of the species was officially downgraded from extinct in the wild to endangered. The return of the oryx has contributed significantly to the physical restoration of the Sahelian soil. One can notice how their hooves create small, water-holding depressions that catch the rare rainfall. Their dung adds essential organic matter to the nutrient-poor earth. These are modest impacts, yet they are sufficient to help trigger the return of life across the semi-desert landscape. And this is not the limit. As tortoises dig into the earth and antelopes redraw ancient migration routes, the Sahel still requires one final component. It needs a species fast enough and resilient enough to connect these scattered pockets of biological activity. That species is the North African ostrich, the fastest-running bird in the world. Once it strode across the vast semi-desert until hunting and habitat degradation caused its local disappearance. In 2016, efforts to return the ostriches to the wild officially began in Chad and Niger. The birds were raised in semi-wild conditions and carefully monitored before their final release. Early results were highly encouraging for the conservation teams involved. Survival rates reached approximately 85%, proving the birds had retained their ability to cope with the harsh Sahelian climate. Their physical return has brought subtle but measurable changes to the environment. As the ostriches forage and move across the terrain, they disturb the hardened surface of the soil. They leave behind small depressions that collect rainwater and disperse seeds through their droppings as they travel. Like the tortoises and the oryx, the ostriches do not fight the desert's nature. They simply help the Sahel function once again as a balanced biological system. The material is ready to move to the next processing phase without haste. 1,600 kilometers is the vast width of the Sahel, a region that will not be restored by a single miracle or lines of trees drawn across a map. Why do massive projects imposed from the outside consistently fail to halt the encroaching desert? It seems simple to plant forests, but in reality, true recovery originates from the creatures that historically inhabited these plains. Sulcata tortoises burrow deep into the parched earth, creating micro-environments that retain moisture and reawaken life from the depths of the soil. The process is only gaining momentum. Scimitar-horned Oryx traverse the landscape with rhythmic strides, reconnecting ancient migration routes and bringing grasses back to the surface through their grazing patterns. One can notice how the North African ostriches move across the horizon, linking fragmented ecosystems through their enduring and repetitive movements. Every individual species generates only a small physical impact on the environment. But this is just the beginning. When these biological impacts are placed in the correct ecological context, they begin to restore the natural rhythm of the entire Sahel. The fight against desertification is not a battle of force against nature, but a technical process of repairing what has been systematically broken over decades. It only looks obvious that engineering is the solution, but in reality, the restoration of the landscape requires extreme patience. It gets more complex further on. The ability to listen to the environment allows nature to heal itself through its own biological mechanisms. One can notice how the dust slowly settles over the restored corridors, where native species now move freely. Restoring these ecosystems through the reintroduction of the sulcata tortoise and other native fauna represents a sustainable path towards stabilizing the soil. This methodical approach concludes the current phase of the environmental restoration strategy. The land transitions into a calm stage as the biological cycle begins to function once again.